Well, just when you thought a story had died, it comes back. The longtime fans of this channel will well remember this one, as the very first video I posted on this channel a decade ago was an exploration of the science behind a puzzling star known as KIC 8462852, or Tabby star, which for a time was on the table as a potential detection of the activities of an alien civilization due to difficult-to-explain dips in the star's light curve, as observed by the now-defunct Kepler spacecraft. Since it's been a decade, I should give the backstory before the update. The story begins in or about 2015. A citizen science project called the Planet Hunters, of which I was one, were examining light curves taken by the Kepler spacecraft in 2011. That spacecraft was a photometer, and it was a genius idea. It stared at a small patch of the sky in the constellation Cygnus for well over a year before changing orientation and going into a second phase. What it was doing was taking measurements of the light levels of the stars within its field of view and looking for dimming events. Specifically, this was intended to look for exoplanets as they passed in front of their parent stars, blocking light, causing a detectable dimming. This resulted in Kepler finding thousands of new exoplanets. But there were a group of anomalous light curves that didn't fit any known models at the time. Most of those were never looked into, but one specific one was. The star KIC 8462852 by Dr. Tabitha Boyajian and colleagues. The star wasn't just dipping, it was dipping by as much as 22%, way more than a normal exoplanet would cause. For reference, if you looked at a similar circumstance from afar at our own solar system, Jupiter would only block about 1% of the sun's light. Whatever this was, it wasn't a normal situation and involved something with a very large footprint indeed. Some more data was taken and it was shown that the system lacked a strong infrared signature. In short, dust disks around stars glow in the infrared. The dust absorbs light and then re-radiates it as heat, just like the hood of your car does if it's in the sun and gets hot enough to fry an egg on. But without infrared, it means that if dust was the culprit, it was cold. Boyajian and colleagues suggested that it might be due to a hail of comets entering the inner solar system of the star from the far, very cold outer reaches. And the cold dust and gas they were shedding was to blame. But there was a problem. Another paper showed that to produce the effect, an implausible number of comets would be required. Over 600,000 of them in the inner solar system at the same time. Compare that to the solar system. We typically only have a few coming through at any given time, and they do it in wildly different periods. And some don't outgas as much at all as they ended up in close orbits of the sun and are nearly exhausted of volatiles. It pays to note that no other star was doing this in the data taken by Kepler, but subsequently a few others were found doing something like it. The bottom line is that at the time, very few natural phenomena could explain the behavior we saw from this star. Almost everything was eliminated. It wasn't massive star spots, it wasn't anything warm, and so on. That led to the hypothesis that it might be a partial alien artificial Dyson sphere, perhaps one under construction that was dimming. This too was problematic in that even a Dyson sphere swarm would also emit an infrared. That's thermodynamic laws. But the option was still seriously considered in the scientific community. Later developments, however, showed something very telling. When red versus blue filters were applied to a telescope, scientists were able to determine if the blocking was caused by solid objects, as in a Dyson sphere, or very tiny objects, such as dust, by how they blocked the light. A solid object blocks all light. A dust grain only blocks frequencies smaller than it is. It turns out the signature was very fine dust, less than smoke particle size actually. And the nature of whatever is going on with the star was a product of cold dust. And there it sat. The star has continued to see periods of dimming, but not on the levels of 2011. Indeed, a search of archival photographic plates showed that the star had been dimming for many decades, very markedly, but now seems to either be in a quiet period or a period of dissipation, because it now only dims typically by 1 to 2%. Now it pays to mention here that this star is distant. about 1,480 light years, which means that whatever is happening with it occurred nearly 1,500 years ago at the end of the Western Roman Empire. SETI looked for radio signals coming from the star and saw nothing, but at that distance, that was a long shot as radio signals diminish in detectability due to the inverse square law. At that distance, the signal would need to be unrealistically strong. So ultimately, nothing conclusive as to what's happening at KIC 8462852 was ever forthcoming beyond that. It was never established why the dust is so cold, if it was some foreground dust cloud or very distant dust cloud orbiting the star. No strong indications of periodicity were ever observed with it, nor was it established how that dust got there and why it differs so drastically from normal debris disks around stars and so on. But now there is a potential answer, and it's rather odd. In a new paper by Madurga-Favieres and colleagues, link in the description below, they detail new measurements from the TESS spacecraft, which was the replacement for Kepler but radically different in method. It studies most of the sky and can reorient much more capably. TESS discovered a transit of something at KIC 8462852, and it's unclear if it's a planet or a brown dwarf. And researchers then looked at radial velocity data, basically the star itself gravitationally wobbling under the tug of anything orbiting it, that together suggests that KIC 8462852 is orbited by a large object with a period of at least 1,030 days. Ultimately, the researchers found that a companion planet or brown dwarf is the most likely scenario for Tabby's star. It does not immediately explain the dimming, however. Rather, it might give a mechanism for how that is occurring. It's worth noting that there was another question at play early in the story of Tabby's star. There is a red dwarf nearby that was initially suspected to be a member of the system, orbiting the main F3 giant main sequence star distantly. It was later shown that it is not actually related, but some of the groundwork on thinking about cometary disruption do come from that, and how that might produce the dimming event seen. The mass of this object is right in a boundary region between a giant planet and a brown dwarf, but the researchers note that there is reason to believe that it's probably more likely a giant planet. Brown dwarfs and stars actually are believed to form from different mechanisms, with brown dwarfs forming like stars through a collapse of a molecular cloud, and planets which form by accretion in a protoplanetary disk. The KIC 8462852 system, however, also does show brightening events, and these might actually be forward scattering from the dust due to the presence of a giant exoplanet. Or it could simply be gaps in the dust. That's uncertain. What relation this would have to the presence of the dust is uncertain as well. It's possible for the large object to be disturbing comets, but it's also been suggested over the years that a detached and destroyed exomoon might be at fault, or the disintegration of an exoplanet, or some collisional event. But those would not seemingly create the very small dust grain size observed with a star. What could shed light on this, of course, is further observation, but that actually has happened. There were reports that the star was observed using the James Webb Telescope in 2023, but the results of that were never reported. Further observations by Webb and Hubble, however, should be able to characterize gases in the atmosphere of the giant planet, and that would establish that it is in fact an object. This is easy in that it is aligned from our perspective to transit its star, which makes those kinds of observations possible. As to whether they will be done, that comes down to scientists applying for time on the telescopes and whether that's approved. So I guess the main question would be, is the alien option for whatever is happening at the star still on the table? Well, not as it was originally envisioned as a partial Dyson sphere, perhaps under construction. When it was demonstrated that whatever was going on there were not solid objects that blocked light entirely, that idea fell off the table. But the star remained enigmatic, and some have suggested that the dust is from the star itself, undergoing star lifting, which is the artificial alien removal of materials from the star itself. Think of it as mining a star for materials, and what you're not using just gets ejected to blow away with the solar wind from the star. This has enormous problems, however. because the close proximity of the dust to the star would make the exhaust very hot. It would not cool down well, as it continued to absorb light and emit heat as the dust blew out of the system. Thus you would see massive infrared emissions from such an operation, and you would not see cold dust. As a result, the system does still present mysteries and is an enigma, and it's still not clear why no periodicity of the dust dips was ever strongly detected. It should have been, and shouldn't have dissipated as fast as it did. So the mystery remains, and in celebration of a decade on YouTube, my very first video I ever posted, which was on this star, here's my original outro, re-recorded as it was in 2016. Thanks for listening. I'm futurist and science fiction author John Michael Godier, and be sure to check out my books at your favorite online book retailer and subscribe to my channel for regular in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live.